Hello, welcome back student. Today we are going to see the next topic in the unit 2, that is Pushdown Automata, PDA. The short form of Pushdown Automata is PDA, and this is very important topic. Definitely one question will come from here, and why we are using this, that also we will discuss. Okay, so before going to go this lecture, first I will tell you what we did in the last class. In the last class we saw some of the examples, okay, how to convert from context free language to context free grammar. Okay, so that we saw, and in that I left one topic, and that I will tell you, that is from the context free grammar, convert context free grammar to automata, means finite automata, that is how to draw the state diagram from given grammar, that we will see. Okay, but today we are going to see pushdown automata. Okay, in this pushdown automata, the first is like see here in the regular language. What is regular language? Regular language is finite state machine, and we will get the regular expression. With the help of regular language, we will get the finite state machine as well as we will get the regular expression. What about context free language? From the context free language, we will get context free grammar as well as pushdown automata. Pushdown automata. So this is a thing. Okay, so now we will more focus on this. Already we have studied all the things. So this pushdown we are going to study now. Okay, fine. So this is a hierarchical of language. If we have the regular language, then we will do the finite state machine and regular expression. If we have the context free language, then we will do context free grammar and pushdown automata. So here, why the pushdown automata? As I told you, like if we have 0 power n, 1 power n, okay, n greater than or equal to 0, this kind of equation is not a regular language, but with the help of context free grammar and with the help of pushdown automata, we can solve this. Okay, and it is nothing but it is more powerful than which regular expression, regular language will not solve in a finite state of steps. That time we will use the pushdown automata. Means if we have the infinite also, we can solve with the help of PDA, but we need to take some initial value. Means we need to take some value like k value. Okay, that I will explain you in this video. Next, what is a PDA? Is a NFA epsilon with a stack. So what is PDA? PDA has the epsilon as well as it has the stack. It has the stack. So, and you know what is a stack? Stack is last in, first out. So whatever it will add last, that will remove first. So this is, so what the PDA will use? PDA will use the stack to solve the problem. Okay, next, transition and modification to accumulated stack operation. So here the transition is very important in the PDA. How to do that we will see. I will explain you theoretically as well as we will take one of the example and we will solve this. Next, here in this, first we will see what is stack. I think you know what is stack and how does stack helps. What is stack means? Stack is store the data, and whenever we want we will get the data in the form of LIFO, that is we can say push down, push or pop. Because of that the name is pushdown automata. So how does it help? that we will see while doing the practical. Okay. A DFA can remember only a finite amount of information. Yes, deterministic finite automata, what it will do? It will only finite amount of information, limited information, whereas PDA can remember an infinite amount of certain type of information in one memory stack. Here, what is the use of a stack? What is the help? We can store the data, infinite amount of information. Okay, infinite amount of information. So here example, if we have this equation, as I told you, 0 power n, 1 power n, 0 less than or equal to n, it is not regular, but is regular after a fixing k. After a fixing k, if n less than or n, but we don't know any n value, if we have the k, if you can define the k like 3, example here, if you define the language 3, then it will stop after some of the step. So what does it mean? 0 power n, 1 power n, that means equal number of zeros and equal number of ones. So see here, 0 1, 0 0 1 1, 0 0 0 1 1 1. So this is, if we have the k is equals to 3, then it will stop here. If we did not use this one, then it will be a infinite, and this is not a regular language. Okay. So this is about some of the information, and here in the next slide, in a DFA, each state remember a finite amount of information. Okay, as we discussed, in the DFA we have a limited information, finite number of information. To get the information for this 0 power n, 1 power n, 0 less than or equal to n, with the DFA would require a finite number of state using the preceding technique. We need to use the preceding technique to solve in DFA. Okay, next one. An infinite stack solves the problem for this as follows. So how to solve this infinite stacks is, it is telling read all zeros and place them on the stack. That means whenever we have a 0, at that time we need to place in the stack. What does it mean? We need to place in the stack. Okay. Read all ones and match with the corresponding 0 on the stack. So whenever we have a 0, we are adding, we are pushing, okay, in the stack, and whenever 1 is there, when we are getting, at that time we are checking the corresponding zeros from the stack. We are popping. Whenever we have 1, we are popping. Okay. Here in this, equal number of zeros and equal number of ones. So here 0 and 1. First came 0, we added. Next time we got the 1, so we are popping. So 0 and 1 both are equal number of zeros and ones. We will see the example, at the time you will get more clear, but remember the simple thing, whenever we have a 0 that we are adding in the stack, whenever we have 1, we are popping from the stack. Okay, fine. Next, only need 2 states to do this in a PDA. Okay, only 2 states to do this in a PDA. Means how many states we needed to solve this? Only 2 states. Only 2 states. Okay. Similar for 0 power n, 1 power m, 0 power n m n, okay, or n comma m greater than or equal to 0. So with this, similarly we can solve this kind of this kind of language also. So we will take one language and we will solve, but before that we need to know formal definition of PDA. In formal definition of PDA, the push-down automata, first is it has 7 tuples. How many tuples will be there? 7. Okay, but in DFA and NFA we had NFA. So in DFA and NFA we will have 5 tuples, but in PDA it has 7 tuples. So what are the new tuples here? This is called, you can say, toe. Okay, we can say this toe, and here Z0. This is Z0. So you can take Z0 and toe is a new tuples in the PDA. As Q, what is Q? Q is a finite set of state, same as DFA and NFA. What is sigma? A finite input alphabet. Okay, finite input alphabets. Okay, what is toe? Toe is a finite stack alphabet. So whatever you are going to store in the stack, that will represent as toe. Okay, Q0. What is Q0? Same. Q0 is a initial state or starting state of Q. What is Z? Z is a starting stack symbol. This is a toe and this is a stack symbol Z0. Z0 is starting symbol in toe. Need not always remain at the bottom stack. So it is not always will be in the bottom stack. We can remove this. How to remove and how to add, I will explain you at the time of problem. Okay. F. What is F? F is a accepting string, accepting state or final state, which is a subset of Q, which is subset of Q, same as DFA and NFA. Delta. Delta is very important here, the transition function. For the transition function here, delta, Q, state cross, sigma, union, epsilon. As I told you, this is NFA with epsilon. So epsilon cross toe. Cross toe. Whenever we do this, we will get the finite subset of Q cross toe star. Q cross toe star. Okay, Q cross toe star. So this is about the formal definition of PDA. This is very important. Remember this. Just you need to remember this two things. Three things. Delta means transition, and toe and Z0. Transition is very important. Number of state cross number of inputs, finite number of inputs, and epsilon and toe, a finite stack alphabet. Okay, this is called LHS. LHS, left hand side, and whatever we are getting this Q R, this is RHS, right hand side. So this is about push-down automata formal definition. Okay, I hope you understand this. Now we will go to the next slide. Here, as I told you, this is LHS and this is right hand side. So we will elaborate this. Okay, in the part we will see this is LHS and this is RHS. Okay, so Q on the LHS means that at each step in a computation, a PDA must consider its current state. Whenever Q, okay, at the left hand side, that must be considered as current state. And what is toe? Toe is the left hand side, means that at each step is computation, a PDA must consider the symbol on the top of the stack. Whenever we have a stack, maybe you will have some values. So consider that is at the top of the stack. Okay. Third point, sigma union epsilon on the left hand side means that at the each step in a computation, a PDA may or may not consider the current input symbol, that is it may have epsilon transition. What does it mean? Means PDA has the two things, one with the input, another one is epsilon, that we will see in the next slide in with the help of points. Okay. So left hand side, what is the first one? What is a Q? Q is the current state. And what is tau? Tau is the top of the stack, from the top of the stack symbol, whatever the symbol is available in the top of the stack, that will be considered. Okay. Next one is sigma union epsilon. So sigma union epsilon means sometime whatever may or may not consider the current input, that is it may have a epsilon. So we can go with the input sometime, and sometime we will have a epsilon. Okay. What is in the right hand side? Right hand side is finite subset on the RHS means that at each step in a computation, a PDA may have several options. Okay. Like Q on the RHS means that each option specify a new state. Whenever we have a right side, then at the time we will get the new state. Tau star on the right means that each option specific 0 or more stack symbol that will replace the top stack symbol, but in a specific sequence. As you know, whenever we have a star means 0 or more. Okay. Stack symbol that will be available in the stack, and that will be replaced in the form of sequence. Clear? So this is about the transition. Okay. As I told you here, this point, as I told you about this point, may we have an input symbol sometime, or may we have epsilon transition. So here two type of PDA transition. So here can you see QAZ? What is this? Q is the current state, A is a current input symbol, and what is Z? Symbol currently on the top of the stack. Whatever in the top of the stack we are considering, that is Z. Okay. Move to state Pi from Q. Pi from Q. So that is Y1, or we can say this is tau I on the stack, leftmost symbol on the top. Move the input head to the next input symbol. So whenever we have a like this inputs, okay, 0 0 1 1, so when it is finished, this is, then it will go to the next. Our pointer, the next move head, input head to the next input symbol. Okay. First it will do this, second, third, so on. Okay, like this. When we have the input symbol, when we don't have an input symbol, at that time is not considered. No input symbol is read. That means we are using the epsilon. Okay, epsilon. So this is a different, because of that it is two type of PDA. One is with input and another one is epsilon with no input. Okay. So this is two types of transition. Now we will take one example. Okay. We will take one example to solve this 0 power n, 1 power n, n greater than or equal to. Okay. N greater than or equal to. Fine. So here already it is given. So what is this q1 and q? This one is finite states, and here finite number of symbols. And what is this? This is tau, this is delta, and this is initial, okay, and this is initial, and here this is a stack, okay. We will consider this, like you can consider T0 or Z0. I am considering Z0, and this is final, okay, this is final. So this is we need to do in like we have to take this and we need to solve. So for solving this, first of all, what kind of symbols, string can be valid for this? Is this valid like 0, 0, 0, 1, 1, 1? Is it valid this? Yes, it is valid, because equal number of zeros, equal number of 1. 0, 0, 1, it is valid? No. Why it is not valid? Because here it is telling equal number of zeros and ones, zeros and ones, but here it's 2 zeros and 1 ones, 1. So this will not accept, okay, this will not accept. This is accept and this is not accept, okay. So here now we will do one thing. First of all, we will draw the stack, okay. We will draw the stack. This is stack, and in the stack initially there will be a Z0 initial, the Z0 is there, okay. And here I have the string. What is the string now? I have example, I am considering 0, 0, 1 and 1. So I am considering this string, and you know this string is valid, equal number of zeros and equal number of ones. We will take this string and we will solve here, okay, fine. So first of all, we will do one thing. We will solve this with the help of state diagram. First of all, we will draw this with the help of state diagram. So first is Q1. What is the initial state? Initial state is Q1, okay. Initial state is Q1, already it is mentioned here, Q1, okay. When Q1 on 1, Q1 on 0, sorry, Q1 on 0, here our mark is here, now our header is here. So when Q on 0, okay, when 0, okay, after that we need to check what is present in the stack. What is present in the stack? What is present in the stack is Z0. What is the top? Z0, okay. When Q1 on 0, this is taking the stack, whatever the stack in Z0, that is we are checking. And as I told you, whenever we have a 0, what we need to do? We need to add in the stack. So first of all, we need to remove this Z0, okay. We need to remove the Z0, then we need to add, okay. This is first. Now in the second stack, I will draw second one, okay, and this is a second. Here this is Z0 and 0, this, and our header is now here. Okay. In the first step my header was here, so 0 comma Z0, okay, and what we were getting, now we need to simply add this whatever is present in the stack, Z0 0 Z0. So this is your answer. That means whenever Q1, whenever Q1 on 0 and stack is Z0, at that time we will get the answer is 0 Z0. I hope you understand this. Did you understand this? If you did not understand, we will go back to our PPT. Here, can you see this equation? Delta Q A Z. So already we have a equation. I will write here. What is the equation? Delta Q comma, okay, what is initial state? Initial state is A, I am considering, and what is this? Z. Z means whatever in the stack. With the help of this we are solving. We are solving this. Okay, what is Q? Q is Q1. What is A? A is 0, whatever the input is there. Then what is Z? Z is whatever is available in the stack, that is Z0. So what the answer we are getting here? What the answer? P1 comma Y1. That means here we can write here Q1 comma, as per this P1 is nothing but first one, Q1 comma, what is the answer we are getting? 0 Z0. Okay, this is a answer with the help of this. Okay, what is this? P1 is this, or you can use the toe. So this is the first step. This is a first step. Now the next one is here we move to here. Move to here. Next, our header is now here and in the step 2. So if Q1 on 0, okay, write it, Q1 on 0 comma, Q1 on 0, input is again 0. So what will be the Z? Where is in the stack? In the stack this 0 is pointering. So 0 comma 0, 0 comma 0. So here, as we did here, we need to remove this from here. Okay, we need to remove here and we need to add in the step 2. In the same way we need to add in stack, Z0 will be same, and we need to remove and add this 0 and this 0. Okay, here we need to remove and here pointer will be 0. So after removing this 0 and again adding, so whatever we are adding is that we need to write here. First you need to write the state, then 0 0. Okay, 0 0, wherever the pointer was there, and whatever you are adding here we need to take this 2. As we already discussed, whenever we have a input is 0 at that time we need to add in the stack, we need to add in the stack. Okay. So, this is first. Now, our header is moved to next, our header is moved to next. So, this is our next input, this is our next input. So, how to do this? Whenever we have a 1, whenever we have 1, so go here and see, whenever we have 1, what we need to do? Whenever we have 1, match with the corresponding 0 on the stack. Okay. So, whenever we have a 1, we need to match in the stack and we'll move to the next state. Okay. So, here move to the next state. Okay. And what is the next state? Q2, and when Q1 on 1, okay, and what is at the top is 0, whenever it is in the top 0, at that time we need to take, like it is going to Q2, okay, 1 on 0, whenever we have 1 on 0, and this is called epsilon, means we are removing this. Okay. What is the fourth one? What is the fourth one? Fourth one stack is 1, 2. So, here Z0 will be there, Z0 is there, and we here 0, and we remove this. Okay. We remove this 0. Why we remove? Because whenever we have 1, corresponding 0 from the stack we need to remove. Okay. So, this is what happened when we have the 1. Once again I am telling, where is my pointer here? My pointer is here on the 1. So, Q on 1, comma, and what is at the top of the stack is 0, 0. Whenever we have like this, so where it is going to Q2 on epsilon, Q2 on epsilon. When we are popping that is epsilon. Okay. So, clear. So, next is pointer is moving to next, pointer is moving to next one. Okay. So, next one, so what is the next state we have now? We have Q2, Q2 state we have now, we finish Q1. So, what is the next state? Q2. So, when we have the Q2, Q2 on 1, Q2 on 1, Q2 on 1, okay, and what is at the top of the stack now? Top of the stack now is 0. So, 1 comma 0. Whenever we have like this 1 comma 0 in equal number of zeros and ones, at that time we need to take Q2 epsilon, Q2 epsilon. Okay. So, whenever we have Q2 1 0 is going to Q2 epsilon. Okay. So, what is our next pointer? Nothing. We finish the string, we do not have the string. So, at that time we will take epsilon comma, what is in the here 4 is finished. Now, we have the fifth stack. What is our fifth stack? In the fifth stack is only Z0, and this is the pointer, this is the pointer. So, epsilon means we do not have anything, that is epsilon here. So, here what is Z0? Z0 is going to Q2. Whenever we have this, then it will go to the final state. that will go to the final state. So what is our final state? This only. This only, Q2. Okay. This, the last point is epsilon, okay, epsilon comma Z0 is going to Q2 on epsilon, Q2 on epsilon. Okay. So this is the final state, we got it. But here, once again I will repeat this. Okay, once again I will repeat this. So here, as we have mentioned here, whenever we have 0 power n, 1 power n, n greater than or equal to 0, at that time capital M means how many state will be there? 2 state. We have Q1, Q2, and 0 comma 1 is numbers, alphabets, and L comma hash will be like this is toe, whatever in the present in the stack, and delta, and Q0 is the initial state, and hash is nothing but the input in the stack, whatever the finite steps, finite symbols are there in stack, that is Z0, and phi is nothing but like a final state. So here in the first one, Q1 on 0, Q1 on 0, we have taken the string this, and first our stack will be like this. Okay. Next, Q1 on 0, Q1 on this 0. Okay. And what is available in the stack? Top of the stack is Z0. So Z0. So first it will remove from here, remove Z0. Okay. Remove Z0 and add here, add Z0 and 0. Okay. Both we need to add here. So where it will go? It will go to the Q1 state, 0 Z0, 0, this one 0 Z0. Okay. So this is the thing. Why we are adding 0 in the stack? Because that is the rule. Whenever we have a 0, that we need to add in the stack. Next, Q1, our header is moved to the next symbol, okay, next finite number of symbol, that is 0, when another 0, comma, and what is at the top of the stack is 0 only. So 0 comma 0, then 0 comma 0, then we need to remove from here, remove this 0 and adding here 0 and 0. These two we are adding here again. This is a rule. First we are removing, then we are adding. So when we add, then we will get the 0 0. Okay, 0 0. Next, when our header is moved to the next one, so Q1 on 1, okay, Q1 on 1. So whenever we have 1 and in the stack if we have 0, so at that time we need to pop the data from the stack corresponding 0. 1 comma 0 is go to the Q new state and it will give the epsilon. Okay. Whenever we are popping, you have to go to next state or you can go to some state. So here we got the next state Q2. Okay. We got the next is Q2. From the Q2, what is the heading? What is the, where is the header now? Where our header is at the last one, in the last. So here Q2 1 comma 0. What is 0? 0 is in the fourth stack, 0 at the top of the symbol in the stack. Whenever we have 1 0 at that time, we will get Q2 epsilon. Okay. after finishing this string, the last will be the epsilon. When the epsilon is there, at that time it should go to z. In the last we will have the 0 z0, then it will go to the final state, then it will go to the final state. But here we need to check, like we are accepting this, when should not be accept, that code also we need to write here, that also we need to write here. So let's see here, I will tell you. Now we will see the function. Based on this we can write first, what is the first one? When q1 here delta, okay, q1 we need to do this, q1 comma 0, this one, and what is our z? That is z0. Whenever we have like this, so what the answer we are getting? We are getting q, we are getting q1 comma 0 z0, we are getting this, okay. When we have this delta q1 comma 0 comma z0, at that time we are getting q1 comma 0 z0, okay. Next is delta, okay. So here we have taken 0, so we can take on the same stack, we can take q1 comma 1 is z0, that is 5. Why we are writing this? Because whenever we have 1 and that should be 0 in the first, that should be 0 here, then only it will accept the string. So whenever we have q1 comma 1 comma z0, that is 5, that means reject. So whenever we have like this, then our language will be reject, okay. This is because what is the one work? Whenever we will get the 1, 0 should be available in the stack. If the 0 is not available in the stack, that means our this condition is not satisfying, okay. So this is second. Now the third one is, I am seeing this and solving. Third, delta, what is this next one? q1 comma this 0, and what is the in the stack? That is also 0. That what the answer we are getting? We are getting q1 comma 0 0. We are getting q1 comma 0 0. Okay, we got this. So we completed this one, we completed this one. Now fourth one delta, okay, q1 comma 1, q1 comma 1 comma 0. So whenever we have like this 1 comma 0, we need to pop this 0 from the stack. So that is going to q2 epsilon, okay. When we remove 0 pop from there, so we will get the epsilon, okay. Here what we got here, the same thing we will get here. Next, fifth one delta, what is the new state here? We have the new state is q2 comma 0, what is the next header here? q2 comma 1, 1, okay, q2 comma 1, and what is available in the stack is 0. That is, then we will get the answer whenever we have 1 0, that q2 epsilon only, because here also we are popping the data from the stack. Next, delta, is there any string available here? 0 0 1 1, we finish it. So next is q2 epsilon, and what is available in the last is z0. So where it will go? It will go to the final state. So what is our final state now? Same, q2 epsilon, q2 epsilon. So this is our final step, final state. Okay. Now here, okay, so here after this 7th one, we need to check delta. Already we finished, but here after this our stack is empty. So q2 epsilon, here nothing. Okay. So what the answer we will get? We will get the same thing, epsilon, we will get here 5 empty, we will get the empty. Okay. And in the same way q2, how we did here, q2 epsilon z0, in the same way we need to do delta for the q1 also, q1 epsilon z0, where it will go, it will go to q2 epsilon. That means from the initial state, after this we are going to the final state. So check in the graph here, when q1 on epsilon is going to q2. Okay. So whenever we have q1 epsilon z0, at that time it will go to the q2 epsilon. Okay. So this is about the example of PDA. I hope you understand this, and I shown you somewhat easy method with the help of like this. Otherwise in the exam actually you need to do like this. Here the step 1, whatever we did there, the same thing, same answer is here. q1 0 comma hash is taking hash. Okay, q1 l hash. So here what we have taken, 0 hash l hash, means z0, in place of z0 it is considering the hash. Okay, but because of that I only shown you, in place of hash we will consider as z0. Okay, for easy understand purpose. So this is delta, q1 is z0, then it will be 5, illegal string and rejected, as I told you. Okay, and this is q1 0l is q1 ll. LL means 0 0 0 0 0 comma 0. Here we have taken directly 0 comma 0. This is also completed. Okay, this rejected and this is completed. Next, q1 on 1 L, where it is going, q2 L. L is nothing but 0. Okay, q2 1 on L, q2 0. The next also is correct. Next, q2 epsilon is z0, where it is going to q2 epsilon. So if epsilon read and stack hit the bottom except, okay, it is except, means this is a final state, final state. Next, q epsilon L, anything that will be illegal. L is nothing but like still if something 0 is there or something is there in the stack, that is 0, that is illegal string. This is also rejected. This is also rejected because we must have equal number of ones and equal number of zeros. But if still something is available in the stack, then it will be rejected. Next, delta q1 epsilon z0, what we are getting? q2 epsilon. So here n is equals to 0. Now it is finished. So this is also accepted. Fine. So this is about the equation where we solve. Now we will do one thing. Goal, acceptance. Read the entire input string, terminate with an empty stack. Means read all the string, this, and empty the string, sixth one. Okay. And here informally we will take one example, we will take one string and we will see whatever we generated, it is correct or wrong. Informally, a string is accepted if there exists a computation that use up all the input and leaves the stack empty. How many rules should be there in delta? Here, like see the same thing here, whatever this one, the same thing, and it is taking this string, taking this string. In the first one, in the first string, it is first string q1 comma a. What is our input? 0011 hash. So first it is taking in 0, okay, and that 0 is converting into L. That 0 is converting into L. Okay. Next, what is remaining? 011. Q1 11. So what is this 0? We stored in the stack. So whenever we have a 0, that we are storing in the stack, and that is representing here as L. That is L. Okay. Now I am taking Q1 on 1. So this 1 and this L should be removed. So Q2, what is remaining here? 1L. And what is remaining in the stack? Only 1L. Okay. So Q2, when we remove this, we will have the epsilon, and from this 2 remove. So here just remaining hash. Hash is nothing but Z0. So fine. So now Q2 epsilon, when we remove that also it will be epsilon. So answer is accepted. That means equal number of zeros and equal number of ones. If we take the example of this Q0, first 0 we are adding in the stack, yes. Next Q1 and this one and this 0, whatever we stored in the stack, that is removed. What is the next one? Q2 1 Z0. When we have 1, we need to pop from the stack, but in the stack does not have any zeros available in the stack. That means this string is not accepting the 0 power n, 1 power n, n greater than or equal to 0. It is not accepting this one. This is accepting. I hope you understand this. Okay, this is important. If you did not understand, just see again the video, and for this video if you miss any one of the step, then you will not understand. Okay, thank you very much. We will see you in the next class.